Hey, hi everybody. Welcome to CoreStack Academy. Um, Today we are diving into one of the most powerful patterns in cloud architecture, the SNS plus SQS fanout. We are going to look at how a single producer can notify multiple systems simultaneously using a decoupled pub sub pattern. Let's get started. So the problem, tight coupling. Before we look into the solution, let's understand the pain point. In traditional systems, a producer might try to call multiple APIs directly. We call this spaghetti architecture. It's a nightmare to scale. If just one downstream service is down, your entire request fails. Plus, every time you add a new service, you have to go back and rewrite your producer code. That's tight coupling, and we want to avoid it. So, what is SNS? Amazon Simple Notification Service. Think of it as a post office. In- Instead of producers sending a message to a specific person, it publishes to a topic. SNS don't care who is listening. It simply broadcasts that message to all active subscribers instantly. It's a fire and forget service designed for high throughput. So, what is SQS? Amazon Simple Queue Service. If SNS is a post office, SQS is a waiting room. It's a buffer that stores messages until a consumer is ready to process them. This is crucial because it ensures that even if your consumer application crashes or gets a spike in traffic, no data is lost. It just stays safely in the queue. So, what's the difference between SNS versus SQS? A common question is which one should I use? Well, they serve different purpose. SNS is about push and broadcasting to many. SQS is about polling and guaranteed delivery to a single consumer. When we integrate them, we get the best of both worlds. A broadcast system that includes a safety net for every single subscriber. Here is a fan out architecture we are building today. We have a .NET Producer API at the start. It sends a data to a central SNS topic called Customers Update. Subscribe to the topic are two independent SQS, customers and customers 2. This allows two different microservices to work on the same event independently. So the magic happens right here in the center. Notice the producer only send a one message. SNS handles the heavy lifting by automatically duplicating that message for every subscriber. Both queues receives an identical JSON copy at the exact same time. This is how you achieve true one-to-many communication. So let's get into creating an SNS topic in AWS. So you can select a standard. You can give the SNS um, topic name, customer updates. Everything is optional here. Right away, you can create a topic. Okay. As soon as you create a topic, you need to click on the subscriptions and you create the subscription. So you need to select the topic ARN, that is customer updates, and the protocol, Amazon SQS, and the endpoint. So we are planning to send the message, we are planning to subscribe this SQS queue to our topic. That's all. Click on create subscription and you do this. You go to the subscriptions again, click on subscription one more time and select customer updates. Now again Amazon SQS. Now select customer 2 and click on subscription. At this moment we have successfully created one topic and able to um, subscribe 2 queues to our newly created topic. Now there's a small thing here that is called access policy. By default, AWS services are locked down. So what does it mean? So we got the 2 queues which are created before. So we also subscribed queues to the newly created topic, but we did not create the handshake. That is, the policy essentially says, I trust this SNS to send messages into this queue. Without this handshake, your fan out won't work. So let's go to the SQS. So this is our customer's SQS. And you see, we have created a policy that is, yeah. So as you see here, we are allowing the permission to send messages to this SQS queue with this policy. So you need to add this particular policy in your subscriber, that is customers SQS queue. As you see, we are allowing the message to be sent from this SNS to into this queue. And the same way this applies to customers too as well. Okay, so here also we are doing the same. We just uh, adding this piece of um, code to allow the SNS messages that got published to the topic and to be allowed into this queue. As you see here, we are allowing the messages to be um, sent from SNS. Yeah. So this is the policy need to be added. So now let's go into um, our producer code and see how we um, publish a message to our topic. So this is a simple code application, a simple customers API. I quickly go through um, this controller. This controller is simple code application where it creates a customer and get the details of a customer and update the details of a customer and delete the details of a customer. Okay. Hmm. Now let us see what is inside this create async. We are getting the existing details. If the existing details, if there are any existing details in our database, we are simply um, simply saying that a user is already existed in our system. Else we are creating a user and we need to focus if the this piece of code. So this is where we are publishing our messages to the SNS topic. Go to the implementation again. So this class is responsible for publishing messages to Amazon SNS. We are implementing SNS Messenger. To communicate with SNS, we are creating a client um, of type Amazon Simple Notification Service. You need to go to the um, um, Nugget packager and download this particular package. Next, we getting the details of topic from the SNS app settings.json, and um, we are trying fetching the topic here um, into this underscore topic here. Through the dependency injection, we are instantiating these two objects through dependency injection. In this publish message async, first we are getting the topic ARN. As you see, let's go into this, go to the definition. In the topic ARN, this we retrieve the topic ARN and store it in topic ARN variable. Now we are creating the object of publish request. It has public request object. It has three properties, that is topic ARN, message, and we are serializing the C# object into the JSON, and we are creating message attributes. It's a dictionary, key as string and value as message attribute. Let us look into the properties of message attribute value object. It has two properties again, data type, string, and value. It's just a attribute customer created. After creating this publish request object, we are sending um, the request to SNS topic through publish async method. Okay, and let us quickly go through how a consumer applications look like. So it's again we are creating. We need to in you know get the we need to get the SDK from a Nugget packages to access Amazon SQS client. We get the QURL and create receive message request. Receive message request has three properties again, QURL, attribute names, and message attributes. So with this SQS client object that we created, we um, get the messages that are available in our SQS queue by sending request message request object and a cancellation token. It's just a while loop. It continuously polls for messages from the SQS and displays the messages here. So let me quickly the application is already running. So let me create quickly apply a breakpoint. So in our producer API, so let me go into the controller, that is customer controller, and create put a breakpoint here. Okay, from here let me create a new SNS. Let me create a customer. As you see, we got the breakpoint here. So go into the create a sync. There is no existing user. Yeah, it's a valid GitHub username, and converting the customer object to customer DTO. We have created the customer in our database. Now we are publishing the message. We got the topic here, and we created publish request, and we are publishing the message. Okay, so you see the message ID starts with E612, and let me go. I'm simultaneously running two applications, two consumer applications, since two SQS are being subscribed to our topic. Um, so one is just the customer. Um, One is just a customer and another one is customer 2. So if I move down, scroll down and see, yeah, so this is for this is a message we retrieved from customers to SQS queue. Yeah, customers to SQS queue. As you see, E61 is the ID, E61 is the ID, and we see SNS, SNS, SNS. So this is um, the message we retrieved from customers to queue. Let me see why we did not get the message for customer from customer queue. Um, Customer updates. Let me create the request one more time. Yeah, now we have received it. Um, ID is BA79. Yeah, here 8F2F and 8F2F. Yes, we received messages from customer. Here I did not give any um, argument, so it fetches the value from customers queue. And let me go to the customers too. So we also received the message 8F2, 8F2. So here I given the argument as customers 2. Yeah, so we retrieve the message from customers to queue. So this is how um, the messages that are published in topic are being retrieved by its subscribers. So let me go back to this PPT again. We have done this step. So key takeaways. Let's wrap up. Remember the three pillars, because why this is scalable, because you can add 100 more queues without changing your producer code. Why it is reliable, because SQS buffers your data a long time. Even the end consumer is down for some time. The messages still be there in the queues and you can process them later. And the cost, because it's all serverless, you only pay for the messages you send. Thanks for watching. Happy coding and happy learning. Goodbye. Take care. Bye bye.